So we're picking up where we left off in the last video. We talked about total cost and marginal cost. And now we need to talk about fixed versus variable cost. And fixed costs are just costs that don't vary uh, with the quantity of the output produced. These are going to be things like land, equipment, rent, anything that doesn't change based on the amount of output you're producing. Contrast that with variable costs, which are costs that vary with the quantity produced. These are going to be things like wages for your workers or material inputs, things that as you produce more, you have to buy more or pay more in wages. And so total cost is fixed cost plus variable cost. So here's a hypothetical example. We have different amounts of quantity we're producing. We have a fixed cost of $100, which is constant no matter what our quantity is. And then we have variable cost, which is increasing as the quantity is increasing. And then total cost is just going to be the sum of fixed cost plus variable cost. And in case you had any doubt, we're going to plot all this too. So our fixed cost is 100 at every unit of output. And so when you graph fixed cost, it's just a line straight across. Our variable cost, however, is changing. And our total cost is going to be if we take the variable cost and add the fixed cost, which essentially means we're going to shift our variable cost curve up by the amount of the fixed cost, which is 100. So it shifts up by 100 at every point. And so the total cost curve is going to be parallel to the variable cost curve, but like I said, 100 units higher. So there's just a few more cost definitions we have to cover. So we have fixed cost and variable cost. There's also what's called average variable cost. So we say average variable cost, it's going to be the variable cost divided by the quantity being produced. We also have what's called average fixed cost, which is going to be the fixed cost divided by the quantity produced. So let's add that to our table. So we don't have any variable costs in the first entry. At 1 unit, we've got 70 for our variable cost divided by 1 unit. So our average variable cost is 70. Then we've got 100 divided by 2, which is 60, and so on. We can do this for each level of output. And similarly with average fixed cost, we have the fixed cost, which is 100 for every level of output. And so average fixed cost is just going to be 100 divided by the quantity. So again, not applicable for the first case because we have no output. And then we go 100, 50, 33. And then finally, we have average total cost, which again is going to be, you probably suspected, total cost divided by the quantity. So if you take this column, divide by Q, you'll get the average total cost. Another way to get average total cost is by just adding up average variable cost plus average total cost. So make sure you know how to calculate all these values in this table and where they come from. So now we want to talk about some of the properties of average total cost. So if we plot average total cost as a function of the quantity, typically we'll get something that looks like this. So it's initially decreasing. At some point, it starts increasing. And so in general, average total cost has a U shape. And so why is that? So in this first area where we're decreasing, the falling average fixed cost is pulling down the average total cost. So if you go back to our table and look at average fixed cost, it's getting smaller and smaller with each unit, 100 to 50 to 33 to 25. But then at some point, the average variable cost starts pulling average total cost back up. So looking again at our table, eventually the decreases from the falling average fixed cost get small. So up here, our fixed costs fell by 50, average fixed costs fell by 50, but going from 6 to 7, we're only decreasing average fixed cost by 2 or so. And in the beginning, average variable cost decreased by 10. In magnitude, this is pretty small compared to average fixed cost. And so the average variable cost doesn't have much effect on total cost. However, from the 6th to 7th unit, average variable cost increased by roughly 11, and the average fixed cost was only 2. So down from 6 to 7, the effect of average variable cost is much larger on total cost than in the beginning when we went from 1 to 2 units. And so that's why you get this U shape and have this inflection point. So as you might have guessed, this point has some significance. This is what we call the efficient scale. And the efficient scale is the quantity that minimizes the average total cost. So you find the lowest point on the average total cost curve, whatever quantity that corresponds to, that's your efficient scale. So another property of the efficient scale is it's the point on the average total cost curve where marginal cost intersects it. So typically you'll get something like this. This is your marginal cost curve, and it will intersect the average total cost curve at that efficient scale. And this is just a mathematical prerogative. If marginal cost is below average total cost, with every additional unit of output, you're averaging in a number that's below the mean, and so it drops the mean. But at some point, you get a marginal cost that's above the current average total cost, which means you average in a number that's above the mean, and so you raise the mean or raise average total cost. So by definition, the marginal cost curve has to intersect the average total cost curve at its minimum, or the point that is the efficient scale. So we have one more type of cost, or one more distinction we can make between costs, and that's going to be short versus long run cost. So in economics, we define the short run as the time frame where some inputs are fixed. So for example, if you're renting a building to run your business, the short run is the amount of time that has to pass before you can change your rent payment. So if your lease is for a year, the short run is a year for you with respect to that rent payment, because no matter what, you have to make that rent payment each month. However, after a year's up, that rent payment becomes variable. You can rent a new building or renew your lease, and so that input is no longer fixed. The long run is going to be defined as the time frame where all inputs are variable. So again, if you can change your rent year to year, rent becomes a variable cost. So that's the long run. It's whatever time frame you need to pass before you can change your fixed cost. So the reason we care about short versus long run costs is that in the long run, the average total cost at any given quantity is going to be a cost per unit that uses the most efficient mix of inputs. So I know that's confusing. So let's look at an example. So in this example, there's some kind of business, and they can choose between 3 factory sizes to lease. There's going to be a small, medium, and large. So then we're going to get average total cost curves that look something like this. So this is average total cost for the small factory. Got average total cost for the medium company or factory, and then average total cost for the large quantity. And so what this means is that these intersections tell you that anything over here to the left of Q1, it's most efficient to use the small company. That's going to minimize your cost. It's not even possible to use the medium company or factory until you produce at least this much. The interpretation is that the factory has some minimum amount that once you start producing, you have to produce at least that much. And again, at this point, Q2, this says that if you're producing more than Q2, then the large factory is going to give you the lowest cost. So I want to make this clear. I'll explain it in a little bit of a different way. Let's say you're producing this much. We could either use the medium factory or the large factory. However, if we use the medium factory, this is going to be our average total cost. Whereas if we use the large company factory, we're going to have a lower total cost for that same level of output. On the other hand, if we produce this amount, which is a little bit less, it's the other way around. The large factory is going to result in a higher average total cost than the medium factory. And so what I said on the last slide, in the long run, the average total cost is going to use the most efficient mix of inputs. What that means is we're in the long run, which means we can switch between factory sizes because all inputs in the factory as an input are variable in the long run. So the long run average total cost is going to be a combination of all the short run total cost curves. So we start out using the small factory. When we get to this point, we switch to medium, and then we use the medium factory until we get to this point, and then switch to large. So in the real world, there's not just 3 factory sizes. There's lots of factory sizes. And so you might get a bunch of different cost curves that look like something like this. And so your long run average total cost is going to be the combination of these short run cost curves that give you the lowest long run average total cost. So basically just trace out the minimum of all these short run curves or these individual factory curves, and that will give you the long run average total cost. So we'll call this a typical long run average total cost curve, as in this is the general shape you're going to see. So I'm going to redraw this a little bit nicer. So there's our typical long run average total cost curve, and we can divide the long run average total cost curve into 3 distinct regions. There's this region where we're decreasing. There's a region where we're flat, and then there's a region that's increasing. So this region here, where we're decreasing our average total cost as quantity is increasing, if that's true, we say that this region satisfies increasing economies of scale. And if a firm is exhibiting increasing economies of scale, like I said, that just means average total cost is falling as quantity increases. This next region, which is here, average total cost is not really changing as quantity increases. In that case, we say there are constant returns to scale, or in other words, average total cost stays the same regardless of Q. And then finally, we have this last region. We say that this level of output, we're experiencing what we call diseconomies of scale. And that's going to be defined as an area where average total cost is increasing as quantity increases. A note on terminology, sometimes instead of increasing economies of scale, you might just hear increasing returns to scale. And for diseconomies, you might also hear decreasing returns to scale. Those mean the same thing. So intuitively, these regions kind of make sense. When you start producing, you're not very efficient. It's always efficient to make more of something than less, at least when you're starting from zero. Think about a factory and an assembly line. If you're just making 1 unit, it's really expensive to create a whole factory and machines to make that 1 unit of output. But if you're making thousands of them, you start to get more efficient and it costs less to make each individual unit. But eventually you are producing so much that you just can't handle that amount of output, and cost starts to rise. You can think of this as you're producing so much that you start have to renting more start having to rent more space to store the output you're producing before you send it out, or you have to start building more machines because the ones you have aren't capable of producing the output. And so that's why average total cost might be increasing eventually as you start producing more. So that's it. That covers everything for production and everything we need to know about costs. I know that was a boring unit, and I don't even know if anybody's still watching this video at this point. So if you're hearing this, pat yourself on the back for making it through, and let me know if you have questions.